Well, good morning, or I guess good afternoon, once again, depending kind of where you are. I want to thank you for joining today's webinar on getting started with CloudScript. My name is Tom Robbins. I'm with PlayFab, and CloudScript, I think, is one of the most exciting things that we have within our set of features. And I'm really excited today to have Brendan here, who is our Senior Developer Success Engineer, who's going to spend some time providing us information on getting started with CloudScript. And as always, this is an incredibly important activity, and we really appreciate folks spending time. If you have questions, please go ahead and send them in, and we'll do our best to answer them. And also, if you haven't noticed, we are providing a regular series of webinars, and we're going to be posting a bunch of new ones over the next couple of weeks. If you have more interest in a specific topic, please feel free to send an email to webinars@playfab.com, and we'll see what we can do. So without further ado, I'm going to turn it over to Brendan. We're going to hop into getting started with CloudScript. Brendan?
Hey, everybody. So welcome to getting started with CloudScript. As Tom was saying, CloudScript is really one of the more interesting services that we offer because it provides the ability for you to do almost anything you can think of that isn't provided out of the box with PlayFab. It's a way for you to have your own hosted JavaScript running in our service. There we go. So that you can have logic which is server authoritative, which it goes beyond the services that we already offer as part of PlayFab. So as an overview, what I'm going to talk about here is I'll give you some of the fundamentals of what CloudScript is, talk about adding a script and doing revision control on it, how to make a call to one, using Photon Webhooks with CloudScript, which Photon Cloud is the product of the Exit Games team, one of our partners. What you can do for debugging your cloud scripts. Now, each of those topics, I need to point this out at this point, we have some documentation on our site, both in blog forms and tutorials, which go into a lot more depth on those. So I'll be covering them at a fairly high level. What's really going to be some of the more interesting component of this, though, is the usage scenarios, because I want to talk to you about some of the examples of ways in which you can use CloudScript to extend the functionality of your game. Let me give you some pointers on specifics of how to implement them. I'll also point out what limitations there are on how you can use it. Obviously, you wouldn't be able to do an unlimited number of things with it. If you were to call millions of API calls, for instance, that would definitely be something that we wouldn't be able to support as a service. So I'll talk about the specifics of what you can and can't do with it. And then I'll give you a few resources at the end, some pointers on places you can go to learn some more. Okay. So CloudScript, as I said, it's a set of JavaScript handlers that you write. We are looking at doing a C# version in future. If there are other languages you'd like to see us support, please do let us know. Right now, though, it is JavaScript. All of the cloud scripts execute in the context of the user that caused the script to be triggered. So all scripts are run through an action, which I'll show you later, coming from the client. And when it runs, the script knows the player and therefore the PlayFab ID of the user that caused it to execute. And so you can take advantage of that as part of the logic of the script. It does work with server authority, and it has access to all of the API methods in the server API set. It can call external endpoints as well. So if you're using another service that has a web-based API, or if you have your own server and you have your web API calls available on it, you can actually call from CloudScript into those as well for additional functionality. So this is a great tool for everything from game updates to cross-service coordination, cheat prevention, all kinds of things. And like I said, I'll show you some specific examples in just a minute. Okay, so how do you add a cloud script? We made this straightforward in the game manager. There are also API calls in the admin API set that you can use for doing these things. But for the purposes of this talk and for simplicity, I'll be showing you the game manager approach to doing these things. So you see on the left, in the upper left there, is what you would see when you create a new title in our service as of today. When you go to the Servers tab, the first thing that will come up is the Cloud Scripts subtab. And the script that will already be preloaded for you is our basic sample script. You can think of it as a hello world, but it goes beyond that. It has a number of handlers in it that show you how to do some basic things. Okay, and then when you look in the lower right, what you see is what you get when you click on the Create New Revision button. It asks you where this file is on your local system. You pick your file and you upload it into the service. That results in a new revision being created. There you can see the net result. In this case, I've uploaded a simple script that I put together just for some testing that I was doing. What you see at the top there, the level rewards, is just a definition of some basic rewards that I had for, you can see the handler there below, on level complete. So the concept of the script that I uploaded here was the players playing a multi-level game. Each time they finish a level, I want to give them some reward. Now you'll notice the button there, Deploy Revision 2 to Live, and that's because this is part of the revision control system. So you've got 2 revisions at any time that you can use when you're making a call. The one that will be your test version is the latest version. So there it says Revision 2 at the top. You'll note there's no check mark next to it. We've not deployed it to live. So that's the version that would run if you're running the test version. And then if you run the live version, it would be the one with the check mark. That's the deployed version. So if Revision 2 were deployed to live right now, both test and live would run the exact same version. And if you uploaded multiple additional revisions, Revision 3, 4, 5, whichever one is the highest revision would be the one that's in test. You can deploy any revision at any time, but note that when you do that, it is immediately the live version running for your titles. So always be very cautious about how you use that button. We also have versions in our system. So revisions and versions. A revision is the iteration that you see here when you're doing your testing and working out the details of a script. The version would be, let's say you're doing a new version of your game and you're changing some fundamental functionality. So you want to do an all new script. So you go over to a whole new version, start a new chain of revisions. And you'll be able to see in a sec when I show you the call. When you make the call to run a cloud script, you're asking for both a version and whether or not it's in test. Now, you'll note that version isn't exposed in the game manager right now. There was some confusion because of the way it was laid out in the game manager previously over how to use versions and revisions. So we're in the process of updating the site right now, and we'll be putting version back out in a way that makes it much more clear how it operates and when you should be using it. So when you call a cloud script, the first thing you do is you query for the cloud script URL. So from the client, you call get cloud script URL. Obviously, you'll be passing in the session ticket for the signed-in user and your title ID. You see where I've commented those out in the Postman style fashion. In the actual body of it, I've included the testing parameter. Now, testing in this case is set to true. So in the previous revision screen that I showed you, revision 2, the one that's in test, would be the one that runs when the script is actually run. The other parameter that you can pass in here is the version. The version by default is 1. And then the response to this call gets you the actual URL that you'll call from your game in order to make the cloud script execute. When you execute the cloud script, you make the call to it, you pass in any parameters. So in this case, I'm calling out to the on-level complete example that I showed you earlier that I uploaded, and I'm passing in as my parameter what level was completed. In the response that I get back, in addition to the standard response code, which in this case is of course the 200 since it passed, you'll get back the handler, the version, and the revision that were run. So on-level complete was the one I ran, version 1. In this case, revision 43. There was some testing I was doing on another title. That's what this is from, just so you know. The custom response data that comes back is the actual result of the execution. You'll note that it's in 2 places. You've got the results above and the results encoded below. This is so that you can use it in whatever format that you need. There's also a log. You see action log there. We'll be talking about logging and as part of your debugging flow in a few. Anything you log using the log functionality would show up here in the action log. And then finally, you also get the runtime. And that's just so that you have some idea of how long the script takes to execute on the back end. Okay, Photon. So we partnered with Exit Games early last year in order to make sure that we could offer Photon Cloud as part of PlayFab. So Photon Cloud, and that's the Photon Real-Time, Photon Turn-Based, Photon Chat, they're all part of our premium tier. If you're a premium tier title, you get them for free. We've integrated with their authentication system such that when you sign a player into PlayFab, you then use the session ticket information that you get back from us in order to authenticate with the Photon Cloud. So you sign them in once, and you're automatically taken care of for both. And we integrated with their webhooks, and that's the important part for CloudScript, because what webhooks are they're a way for Photon Cloud to call into CloudScript for your game based upon actions that players take involving the rooms. So there's a number of actions that a player can take with the room. So the concept of a room, for those of you who haven't had the opportunity to look into Photon Cloud, is it's a space that gets created in the Photon Cloud servers where you can have players join into the room and they can, through that mechanism, exchange data with each other. There are room properties so that when a player joins the room, they get the status of it, that sort of thing. It's a great tool for managing real-time connection between players so that you don't need to worry about things like NAT tunneling, for example, or maintaining those connections. So the events that we get from them, which will automatically trigger a webhook, and by the way, each one of these has a handler in the default script that you get when you create a new title in our service. And if you've got an older title from before we started putting that default script in, the script is also available in our GitHub, which I'll show you at the end of this talk. But the events that can be called out, or that are called out automatically on your behalf, are when a room is created, when a player joins a room, when an event is raised from a room, when a property is updated on a room, when a player leaves the room, and when the room is closed. Of those, the two that probably aren't as obvious are the room event raised and the room property updated. As I said, rooms can have properties, which are just variables that you have on the room so that any player joining the room gets all the information about it. Whenever one of those gets updated, that gets fired. And then the event raised is for arbitrary events that you can define in your game, which you trigger into the Photon Cloud, which then calls over to our through webhooks over to CloudScript. Okay, so debugging. Right now, debugging in CloudScript is fairly basic. We have a log class as part of our JavaScript implementation for CloudScript, which allows you to call a log debug, error, or info message. As I said, all of that gets aggregated up and is passed back to you as results from your script running in the action log. We are in the planning right now on integrating a better debugging system for you. We're very interested in getting your feedback on what workflow you feel is best for this. If you're more inclined towards a purely local debugging experience versus a cloud debugging experience, that's certainly valuable information for us. If there are other features that you feel are needed from a cloud debugger or a local debugger, that's also something we'd be very interested in knowing about. And again, I just wanted to highlight all of the components we're talking about so far. We do have more information available online. If you've got any questions that we don't answer over the course of this webinar, feel free to send us an email at devrel@playfab.com, and we'll make sure to get you the info you need. Okay, now moving on to the scenarios. And this is where things get interesting, because this is where I'm going to be talking about some of the creative things that you can do with CloudScript that go beyond the functionality that we offer, that we give to you just out of the box. So the first one is updates. So you're updating your title regularly, particularly if you're a free-to-play title, or honestly any title, whether you're free-to-play or not, in one of the mobile marketplaces. In managing your community, you're going to have to update your title quite a number of times over its lifetime. As part of that, you may need to change some of the data on a user, on all of your users for that matter, because of things that are changing about some of the fundamentals of your game. So let's say there's items that have been added or removed, or you're changing properties which aren't global. These are things that you're going to have to change across every user. Now, obviously, you can't just make a call to update all the users all at once. Just the very fact of physics means that you would have the first player updated separately from the last player in that list. And if you have millions of players in your list, that could be a significant amount of time, during which, if your game uses any kind of multiplayer at all, those two players might wind up playing together, and then one player has an advantage over the other because he's been updated and the other one hasn't. Okay, so what you do is use internal data to track the player data version. Now, internal data, if you don't remember, we have 3 different forms of data specifically associated with the user. User read-write, user read-only, and user internal. Obviously, read-write can be read from and written to by the client. Read-only can only be read by the client. Internal is the one that the client can't even see. Okay, so you use internal data to track the data version. You could use read-only as well. Okay, in this case, I'm going to use internal. Then you have an on-login handler. The on-login handler is where you put the logic to update the revision of your game based upon the changes that you're going to make. So you'd create a function for each revision update, changing from revision 1 to 2, 2 to 3, 3 to 4, etc. And then what you do is, when the on-login handler gets called, you simply call the most recent version update, and then within it iteratively goes back through the updates. So you call update to revision 4, it calls to update to revision 3 if the player isn't on revision 3, and so on. So you could do this in a number of different ways. So basically, if the player is not at the current version, you call the handler. The handler takes care of updating the player data. Once it's updated, it returns, and you know that the player, as part of the login process, has been updated to your current data set. Okay, player actions. Now, this is largely for competitive games, but it's applicable to a number of others. In this case, we're talking about an action a player takes that you want to have the resolution for it be server authoritative. So in other words, if a player is playing moves in a game where if they're able to adjust those moves from a client, a hacked client could submit invalid moves or moves that maybe they're not allowed to do, things that would give them an unfair advantage in the game and would therefore give them the ability to cheat and defeat any other player potentially. Those things can ruin your game. They certainly irritate your players. So you'd want them to be server authoritative. Okay, so your player selects his moves, takes his actions. You send that up to CloudScript. In this case, what you're going to be doing is you're going to be evaluating all the moves. Has enough time passed for the player to have actually done the things he's saying he's doing? Does he have the items that are necessary in order to take those actions? Are the actions even possible at all for his level, his class? You can use user read-only data or shared group data in order to have the data from the player's move be available both to that client and to any other client. In the case of both data types, you'd simply set the data to be public so that any client on the service can read it. And in that way, you could share move information between players. And obviously, again, on a failure, write it to user internal data so that you can do some tracking on players who might be cheating, and you can evaluate that and decide how you want to work with them. One of the best techniques that I've seen is just, if you have a lot of cheaters or even anti-cheaters, have them play their games together. Don't let them play with people who aren't cheating. That way, it's kind of a level playing field. Okay. Rewards. So obviously, again, if you let the client be authoritative about what they get as a reward for an action, you will have cheaters, and they will take advantage of your game. They will give themselves the best items. They will give themselves items that maybe you haven't even made available in the game yet, but are in your catalog. So in this case, the player actions get sent up to the cloud. Your cloud script, again, evaluates the actions. Are the values they've passed up reasonable? So if your game has a number of points that players can earn as part of playing a level, what's the valid range for those points? How much time does it take for the player to actually earn that many points? There are a number of checks you could do here. They're all going to be fairly specific to the type of game that you're creating, but we can certainly give you some feedback and advice on it if you'd like to share at any time your plans with us. Okay, and again, you'd use read-only data so that the player can then read the data from the service when it's needed. And you write the failure cases out to internal data so that you can use cheat tracking and decide what you're going to do with players who are trying to cheat your system. Cheat tracking, by the way, is great in multiple respects because it gives you insight into not just like how your players are attempting to bypass your system, but also the details on shared cheats. So if you have a suspicion that one player might have multiple accounts, one thing you can look for is patterns of the behavior that they do in the things that you're storing about this sort of cheat tracking. Okay, messaging. Now, push messages do require server authority. So the only way you're going to be able to send them is either having your own custom game server or using CloudScript. We do have the ability to send them through the game manager as well. So if you are dividing up users into segments so that you can do messaging, we have that capability. We'll also be releasing later this year some additional event systems, which will give you the ability to send out push messages in more creative ways. But when you're talking about something very tactical, very granular, like the type of castle building game, for example, where you build up your own environment and then you can attack other players, commonly you will want to notify the other player that they have been attacked, give them the opportunity to retaliate or to come in and fix things up. And you'll usually want to use a push message for that. There's also the scenario where maybe you want to challenge players to come back to play your game again and again by telling them when a friend has beaten their top score. Quite often the competitive aspect will be very enticing to players. So the server API contains the send push notification message. There's also a full write-up on how to use push notification in our service. If you have any trouble finding that, please let us know. We'll get you the information on where you can find it. But in addition to push messages, another thing you can do is player-to-player messages. So the way you would approach this is by using shared group data. And I'll talk more about that in the next scenario as well. Shared group data is an arbitrary data space. It's not associated with any one particular user. It gives you the ability to write a set of key value paired data into a space that can be accessed by your server calls in CloudScript or any players who are attached to the shared group data if it's private, and any client on the service if it's public data. Now, my recommendation, by and large, when you're using shared group data, is to not attach players to it, because that also gives them the ability to write to the data. So it's a great space to use for things that do not affect game balance or player interactions, such as messaging. So in this particular case, attaching players to it would be fine. When you create a shared group data, you give it an ID itself. If this is going to be a message box for a particular player, you may create it with the ID of messages and then the PlayFab ID of the player in question. And remember, in JavaScript, when you're creating the key for any data that you're posting to the system, the string and two-string calls are your friend. That's how you make sure that you're getting the string of the actual value you're trying to use. Right, excuse me, to state that more clearly, you're getting the string of the variable that you're trying to use. If you pass in a variable name as the key on its own, then that key is assumed to be that variable name. It's just the nature of how JavaScript works. Okay, once you've created the shared group data, then if you write into the shared group data with the ID of the player sending the message to the original player, the player who owns the shared group data, you write into it with the key being the PlayFab ID of the player writing, and then the value being the message that he sends with any arbitrary data that you need in the message, both the text of the message as well as anything that you might have as payload that your game uses for processing logic around, associated with that message. Then when the player who owns that shared group data space logs in, you can use a simple shared group data call to check his data space and see what messages are there, grab them, and then wipe those values out so that you don't read them again the next time. And again, shared group data. So one common thing that we hear from people talk about is the need for having multiple columns in leaderboards. This is quite common. You'll see I've got a picture from League here. The other scenario in which it's quite common is racing games or similar. In racing games, you don't just want the time that the player took to complete the track, but also what kind of car he was driving, or maybe the total amount of money that he spent building out all of the custom options on the car. So a way to do this would be to, again, use shared group data. You'd set the data values in it to be public. In this case, definitely do not set any players attached to the shared group data. Again, players attached to shared group data can write to it as well, so they could overwrite data values for other players potentially. So you'd write to this from shared group data, write in the data for any column data that you want for your leaderboard. Again, use the PlayFab ID of the user whose data you're posting as the key, and then the value would be an encoded JSON string containing all of the column data that you need. Then when you read the leaderboard out, what you can do is take the PlayFab IDs of the players coming back in your leaderboard call, because the leaderboard call comes back with PlayFab IDs and their score. Take those keys, and in one call to the shared group data, you can read out the values for those players from the shared group data, getting you the extra columns for your display. Okay, so let's talk a little bit about what limitations that we have on using CloudScript. So an API call is an API call is an API call. Our service is designed for maximum flexibility and scalability. As part of that, that means that each of the modules of the system, whether it's CloudScript or our data stores or any other component, are each independent of one another. That's the only way it's possible for us to be able to scale to millions and millions of users. So because of that, when you make a server API call in CloudScript, to us, that's effectively the same as if you were making that server API call from a custom game server or from a tool that you write. So the total number of API calls that you run in your CloudScript shouldn't exceed 10. And that's partly to make sure that the API call rate is kept to a reasonable rate. And again, if you're familiar with the terms of service, we do call out that you need to make sure you're not kidding us with tons and tons of API calls. Don't tie an API call to your frame rate, for example. This is the way that we make sure that we keep our service affordable for everyone. The other reason you want to keep the total number of calls to 10 or less is because each of those calls is a web API call itself, and so therefore there's going to be some time it takes to make the call. So the more calls that you make in a CloudScript, the longer that CloudScript is going to take to return. Obviously something you want to avoid. Portion control. So that refers to the amount of data being returned by a call into our service. And this applies both to CloudScript and just regular client or server API calls. The key here is to make sure that the total amount of data being returned by any one call doesn't exceed 1 megabyte. That should be plenty for just about all needs, but if you have some specific scenarios that you're trying to work through that you think are going to exceed either one of those, again, please feel free to email us at devrel@playfab.com, and we can work with you to help to either optimize the design or to come up with another solution for you. And then complexity. This is specific to CloudScript, and a CloudScript should run no more than 1 second. Now, obviously, anybody who's worked with servers or any other form of high-end computing knows that 1 second on a server is an insane amount of compute power. So that should be plenty. But again, if you have something that you think is going to exceed that, let us know, and we can certainly talk to you about what options are available to you. Okay, and finally, resources. The base resource I would point you to start with is our CloudScript tutorial on the PlayFab site. It walks you through everything from the first part of this talk at a greater depth and provides code samples that you can use to actually do some experimentation with this. There's also our GitHub, In the CloudScript samples GitHub repo, we have the basic CloudScript, which is applied to all new titles in our service, but we also have a few other examples of things you can do. We did a blog post actually a little while ago showing how to do asynchronous matchmaking, so a completely asynchronous game, doing matchmaking so that you can find a game, post your moves, and then later on somebody else makes their move. We have the full CloudScript that we did as part of that blog and sample available in our GitHub. And then finally, there's a blog post on how we used CloudScript to enable the Dave & Buster's case. That's one scenario that I could give you in addition to the others that we talked about. In the case of Dave & Buster's, they have several games, Speed of Light, Big Bass Wheel, and Tip and Blocks, in which your players, or their players, excuse me, can earn points. Those points can then be turned into tickets on a Dave & Buster's power card, which is actually the physical world power card that you get at a Dave & Buster's store. Those tickets can be used at their stores to be turned in for prizes, for discounts on food and drink, all that sort of thing. So that's an example where we're doing most of the things that I talked about. We do validation on the number of points people are saying they score so that they can't cheat those values. We do calls between our service and the Dave & Buster's service because their service has to be authoritative over the power cards themselves. And in general, we have some calculations in there which are used to determine what the rates are that tickets can be, at which tickets can be converted. If you've played these games, what you've noticed is that you can only convert a certain number of tickets per day, and that's in order to make sure that players who are the most aggressive about playing the game, let's say, aren't disadvantaging their system or costing them more than they can afford in this program. But yeah, the blog post goes into more detail on that, talks about the specifics of how we implemented it and worked with them. And with that, I think we have a good bit of time remaining. So I wanted to make sure I could answer any questions you guys have.
Yeah, we have quite a few questions. And for those folks that are out there, if you have additional questions, feel free to go ahead and send them in. So the first question is, what platforms are supported by push messages? Can you push messages to Windows OS X?
So that's a good question. Not yet. Right now we do push messaging through Amazon SNS. You can enable it with both for both iOS and Android using GCN and APNS. So yes, those are the two platforms supported right now. We do plan on adding Windows support, and specifically for Windows Phone and OS X. I'm trying to think where that is on schedule, actually. Tell you what, if you have a specific date that you're looking for, please let us know at DevRel, and we'll work with you on that. But it is in our roadmap right now.
Great. Let's see. So another question is, we tried to use Photon turn-based webhooks, and it looks like they were having, so should CloudScript receive any webhooks around rooms created, rooms joined? And then also, are there any places they can find logs for Photon server?
So logs for the Photon server, you would need to ask the Exit Games team about that. I'm fairly certain that they do not provide logs from those. But I would reach out to their team to specifically ask about that. They will have the best information about how their service operates. If you've been trying to use Photon turn-based and you're not seeing the webhooks being fired in your CloudScript, I guess my first question would be, please make sure that you're using the app ID from PlayFab. So when you go to the Servers tab on the far right of the subtabs, you'll see there's a Photon tab. In there is the place where you agree to the Photon terms and conditions, and it provides app IDs for all of the Photon cloud services, which are tied to our PlayFab instances. So those are the ones you have to be using in order to get Photon Webhook calls back into PlayFab and to use our authentication. But if it goes beyond that, if that is the app ID you're using and you're still having issues, please reach out to us at DevRel and we'll make sure to get you the information that you need. We'll probably need to do some debugging with you to understand exactly why your scripts aren't being fired.
Great. And then we still have some time for additional questions. If anybody has any, feel free to send those in. One of the other questions that came in, and I guess this is that 10 per second or 10 total?
Yeah, that's a good question. Well, actually, and the funny thing is, since I said a cloud script shouldn't run more than 1 second, it's really both. The way it works is you shouldn't really be calling more than 10 API calls, 10 PlayFab API calls within a cloud script. And it's, like I said, it's both to make sure that we're maintaining the long-term viability of the service so that we're not being overloaded with too many calls. But it's also partly because it is going to take time for each of those calls to be returned. And you really don't want to have your client sitting around for a long time waiting on that data.
Okay. So another question that came in is, I'm new to CloudScript. Is there anything I should think about in the architecture of my game to get best usage out of CloudScript?
Wow. Yes, absolutely. I would say the first thing you should do is sit down and ask yourself what you really want the client to be authoritative concerning. Looking at the broad range of games that are available out there, there's a huge number of things that could be. But some of the examples that I gave are some of the bare minimum things you're going to want to think about. Never have any rewards that are going to the player be client authoritative. Oh, and I'm sorry, I should highlight. What I'm saying is a very generalized statement about what you should and shouldn't do for rewards and for other things. What I'm really referring to is games where players cheating these things could impact negatively your user base and cause people to leave your game. That's specifically what I'm referring to. It is absolutely the case that there are certain game types where it just does not matter at all if players cheat. If your game is purely single player and the players never really see what other players are doing, absolutely doesn't matter at all. If the game is cooperative and you only ever play with friends, usually it really doesn't matter if players cheat, because if they're cheating or even if it's competitive and they only play their friends, if players are cheating only their friends, really that's not usually a big deal for games. But it's something you'll want to give a lot of thought to, is what you want to be authoritative. So again, going back to what I was saying, rewards are usually one thing. Certainly if you have a game which is a competitive leaderboard, you'll want the score to be something which is controlled by you so that you can check to make sure that the players aren't submitting invalid scores or cheating their scores. Wow, there's like I say, there's a huge range of things you could be doing here. If you have a competitive game where players can actually attack each other, cause damage to each other, that might be a case where you're going to want to do some validation on the attack that the player is making, or do the calculation, for that matter, of the actual points being applied against the other player in the cloud. The list, it goes on and on. It's the list of things you might want to consider is basically as endless as the number of types of games that you could potentially create. But in the end, what it comes down to is the question of anything you let the client be authoritative concerning can be cheated. And if it can be, it will be. Really, the frequency of cheating is going to be down to the number of players that you have. And it's not a matter of if players will cheat. It's pretty much a guarantee. For any non-trivial user base, you will have people trying to cheat your system. That's just another way people play games.
Okay, perfect. And if anyone else out there has a question, it looks like we've answered all of the questions that we had in. Once again, I want to thank Brendan for joining us today to talk about CloudScript, and we appreciate everyone taking the time today to join us. As always, we will make sure that we make the video available for playback as well as our slides. And then if you have any questions, feel free to contact us at debrel@playfab.com with additional questions. And with that, I'm going to go ahead and end today's webinar. Thank you, Brendan, for joining us.
Thank you, Tom. Thank you, everyone who joined.